Hi everyone. I will introduce about the training procedure using neural network to do reaction prediction, and I introduce about how to define the molecular graph in last section. And in this part, I will talk about how to learn the knowledge from the graph structure and also how to learn to predict the product of the reaction. Firstly, let's remind something about how to define the molecular graph. We define the molecular graph as G, which contains 4 parts. A, A is the set of atoms. X represents the atom content matrix. And B is the set of bonds. Y represents the bond content matrix. So next, let's talk about how to learn the knowledge from the graph structure. First, I will also take this molecule as input as an example to show how to learn the knowledge. First, I will define a molecular graph using this molecule, and then I will obtain the atoms content matrix X and also the bond content matrix Y. Then I will use graph neural network to update the representation of each atoms. For the specific atom, I will aggregate its connected bonds information and also its neighbor nodes information to update the specific atoms information. And using this way, I will update all the atoms in the whole graph. And after updating, it will the content matrix the atom content matrix will be X prime. And in this matrix, you can see that each the representation of each atom will contain the information of its connected bonds and the information of its neighbor nodes. And then I will define a supervised loss. The supervised loss is the loss function which is defined without pre-existing labels. I define this loss, and I will use this loss function to train the graph neural network to update maybe parameters or weights to let the representation of the nearby nodes are more similar, and the representation of the disparate nodes are highly distinct. So in this way, we use this graph neural network, the representation of each atoms will learn something from the graph structure, because the nearby nodes will share the more similar representation, and the disparate nodes will share highly distinct representations. And then I will introduce how can we use the knowledge we learned from the graph structure to do the prediction, the product prediction. This is the whole procedure of the reaction. When we observe this procedure, we can see that during the whole procedure, there is no atoms disappear or produced newly in this procedure. So the change only happened on the bond. You can see that during the whole procedure, like the arrows shows, there the only change is like the yellow arrow shows, there were some bonds produced newly, and like the gray arrows shows there were some bonds will be broken during this procedure. So if you want to predict the products of the reaction, we only need to predict the bonds among different atoms from these three input molecules. So after we know this, we can define how can we learn to predict the products of the reaction. Firstly, we need to take these three input molecules together to define the molecular graph. And the atoms, you can see that the atoms from these three different molecules are disconnected. And after we define this molecular graph, we can obtain the content, both the atom content matrix and the bonds content matrix Y. And then we will use graph neural network to learn the information from the graph structure and update the representation of each atoms. Then we will obtain the new atom content matrix X prime. And after we obtain this X prime, we will do some maybe linear transformation or nonlinear transformation to predict the bond between different atoms, and we will obtain this new B prime. B prime is the set of bonds in our predicted product. And then we will define another loss function, which is the supervised loss function. Supervised loss is the loss function which is defined using labeled data. Here, labeled data is the set of bonds in the true products. And we will use this supervised loss to calculate the difference between the bonds in our predicted products B prime and the set of bonds in the true products. And using this loss function to train graph neural network to minimize the differences between B prime and BP. Then we can make the P prime more accurately to predict the product of the reaction. So this is the whole procedure of the prediction. That's all. Thank you.